Hello students. Welcome to today's class. We are going to talk about distance and displacement. Before we proceed with today's lesson, remember, in our previous class we learned that position is important in technology, transportation, and our everyday life. We also learned about the difference between position and distance. By the end of this lesson, you should be able to know the measurement of distance and displacement. Know the difference between distance and displacement. Now, without further delay, let us dive into today's topic. Distance is a measure of how far apart two points are. It's a scalar quantity, which means it has only magnitude, but no direction. Meaning that, it tells you how far apart two points are, but not in which direction. Since it doesn't have a direction, it can't be considered as a vector quantity. Distance is always a positive value, as it cannot be negative. Distance can be measured using various units, such as meters, kilometers, miles, feet, inches. The formula used for measuring distance is distance equals to speed multiplied by time. Here are some practice problems to help you understand distance. A car travels at a speed of 100 km per hour for 4 hours. How far does the car travel? Remember, the formula for measuring distance is speed multiplied by time. The speed of the car is 100 km per hour, and the time is 4 hours. We are going to multiply 100 km per hour by 4 hours. The hours will cancel out each other, which will give us 100 kilometers multiplied by 4. So, the total distance is 400 kilometers. Next, we are going to talk about displacement. Displacement is defined as the change in position of an object from its initial position to its final position. It's a measure of how far an object has moved from its starting point to its ending point. Displacement is the change in position, not the total distance traveled. It is a vector quantity, which means it has both magnitude and direction. The direction of displacement is crucial in determining whether it's positive or negative. Displacement is considered positive when the object moves in the direction of motion. In other words, if the object moves from point A to point B, and the direction from A to B is considered positive, then the displacement is positive. On the other hand, displacement is considered negative when the object moves in the opposite direction of motion. If the object moves from point A to point B, but the direction from A to B is considered negative, then the displacement is negative. Here is an example of when displacement can be considered either positive or negative. A car moves 10 meters forward from point A to point B. If we choose the forward direction as positive, the displacement is plus 10 meters. The same car moves 10 meters backward from point B to point A. If we still choose the forward direction as positive, the displacement is minus 10 meters. When calculating displacement, it's essential to consider the initial and final positions of an object. Let's look at the various reasons why it is important to consider the initial and final position of an object. Considering the initial and final positions helps determine the direction of displacement. By considering the initial and final positions, you can calculate the change in position accurately. Failing to consider the initial and final positions can lead to confusion between distance and displacement. The standard unit for measuring displacement is meter. The formula for finding displacement is displacement equals to final position minus initial position, where delta D equals displacement, dF equals final position, D0 equals initial position. Here are some practical problems to help you understand displacement. A car travels 3 kilometers west, and then turns around and travels 2 kilometers east. What is the displacement? To solve this problem, we will first of all decide which direction is positive and negative. Let east be positive, and west be negative. Remember, Displacement equals to final position minus initial position. And our final position is 2 km east, while our initial position is 3 km west. So, our displacement is 2 km minus 3 km, which will give us minus 1 km as our answer, or we can say 1 km west, because west is our negative direction. Alright students. You are doing great. Next, we are going to discuss the differences between distance and displacement. Here are some differences between distance and displacement. Distance is a scalar quantity, which means it has only magnitude. It is always a positive value. Distance depends on the path taken by the object, while displacement is a vector quantity, which means it has both magnitude and direction. It can be positive or negative. Displacement depends only on the initial and final positions of the object. I have 2 assignments for you to work on. Number 1. What is the difference between distance and displacement? Number 2. A cyclist rides 6 kilometers from west and then turns around and rides 4 kilometers east. What distance does she ride? What is her displacement? Good job, students. Before we end today's class, let us summarize on what we learned. Today, we learned about the measurement of distance and displacement, the difference between distance and displacement. Alright students. Great job today. In our next class, we are going to talk about time. Thanks and goodbye.